Thank you. I shouldn't be a climate optimist. You see, I only became a climate scientist because I am deeply attracted to tragedy. As a longtime journalist, I had chased disaster all over the world, and climate change was the greatest catastrophe of them all. So climate science was like a front row seat to the end of the world. This was very on brand for me. But these days, when I envision the future, I actually see a future, a good one. Not in spite of the science, but because of it. Global greenhouse emissions are finally plateauing, and they are projected to start falling soon. Yeah. Wind and solar energy development keeps overshooting expectations. Carbon capture is improving, and nature-based solutions are literally gaining ground. And all of that is obviously really great news, and none of that changed my mind that we were heading toward a very bleak future. What did change my thinking was data. Climate science is a search for hidden patterns that's enabled by data. We gather it from the world, we use it to build mathematical representations of long-term weather trends and how those trends will shift as the climate changes. And then we test those models against real-world outcomes. The more relevant data we put into these models and the better we get at structuring it according to how Earth systems work, the better we can see coming patterns. The better we can predict the future. And we already have. The climate models my predecessors built 50 years ago were based on less data than you'll find in a single high-resolution digital photo. Their models were run on computers with far less processing power than the phones we carry around in our pockets. And yet those bare bones models very accurately predicted the average rise in global surface temperatures that we've experienced over the past few decades. We saw this future coming. So why didn't we act? Well, because those early models weren't very actionable. Because even if we could have said back then that we knew what was going to happen long term to average surface temperatures globally, we don't live globally. We live on little pinpoints spread out across this planet, where temperature is just one of many variables that impact our lives. Precipitation also matters. So does wind and groundwater, so does cloud cover and ocean level and humidity and air pressure. If we are going to plan and prepare for the future, we do need to know what all of these variables are going to be like in the very long run, but also in the springs versus the summers. And this winter, relative to last winter, we need to know if the upper and lower extremes are going to shift and by how much and when. But with a bit more data, our long-term global models became more valuable for more variables at continental scales and annual timeframes. And when we added even more data, these models began informing us about coming climates at even more regional scales and seasonal timeframes. You see where this is going. Data is the key. And today, we collect hundreds of millions of meteorological data points every hour, from sensors on weather stations on land and sea, from radar and aircraft and balloons and satellites. When we feed these data into our models, they become more reliable. They help us see the hidden patterns with greater temporal, spatial, and quantitative accuracy. That's the vital when and where and how much of climate. And that is information we can act on locally and even proactively. It gives us something we can do, something we can actually impact in response to this changing world. I'd like to give you a few examples of how we can employ climate prediction in order to enable action on 3 real and pressing fears related to climate change: food, water, and inequality. We'll start with food. Around the world, many, if not most, of the places where we currently grow our food are becoming less suitable for that purpose under climate change. And we still farm, mostly in the same places, with the same crops, using the same methods year after year. We farmed this way because in the past there was no way to know what coming seasons were going to be like. Farmers knew how troublesome this lack of a view of the future was. For generations, they spent their hard-earned money on almanacs. They turned out to have no scientific value whatsoever, just the hope that a glimpse of the future might help. That's something we now have. I recently led a team of researchers that discovered a pattern hidden in the data that is strongly associated with wheat harvest yields in the US Midwest. In Kansas, our model predicted a very low harvest in 2023. And unfortunately, that happened. Farmers suffered from record-setting agricultural drought that year. Our model also predicted a big rebound in 2024, and that happened too. The signals that tell us that bountiful or meager harvests are likely are in the data more than a year before farmers even put seeds into the ground. I'm proud of this work, but honestly, it's nothing special. Researchers around the world are building similar tools, and farmers around the world are beginning to use them to adapt their planting decisions. No longer based on what was good enough most of the time in the past, but now increasingly on what is most likely to happen in the future. Second, water. This is another real worry, especially here in the American West, where drought has been intensifying, and our models tell us that water is likely to become even scarcer in the future. But the truth is that water doesn't leave Earth. The amount of water on this planet has remained remarkably stable for billions of years. So our problem isn't that climate change is taking our water, but that it is changing the long-term patterns of distribution that we've grown used to. And that is a big crisis if we only know where water used to be. In the Western United States, the way we share water from the Colorado River was agreed upon more than 100 years ago, based on records from the even more distant past. As a result, we over-allocated the water that actually came. But the renegotiations that are underway right now are informed by what our models tell us is most likely to be the case in the future. Research from my university and many others is getting more and more skillful at predicting coming river flows years ahead of time. In the past, water restrictions only ever happened after years of drought. And storage was always limited, even in very wet years. Now, we can act ahead of time to collect more water when it makes sense to do so, and to share it when we need to. Not once we're already in trouble, but when we can see trouble coming from beyond the horizon. Finally, inequality. I'm afraid to say that climate science is not going to fix injustice. But it can be a tool for fixing a loophole that powerful people and industries and governments have used to abuse our world and degrade our environment to the detriment of us all, but especially the least fortunate among us. That loophole works like this. Under nearly every form of law on this planet, we are only held responsible for the consequences of actions that can reasonably be foreseen. So those most responsible for the damages that have already been done as a result of greenhouse emissions can say, how could I have known? And you can't prove it was my carbon anyway. Except guess what? Now we can. I was part of a team of researchers that recently showed that we could demonstrate where carbon polluted air goes after it's created. In this case, these air masses began with intentionally set agricultural fires in northern India, and they traveled east into Nepal, where they settled in Kathmandu, creating a deadly toxic fog. In the past, there was no recourse because there was no way to show the course or consequences of carbon pollution. Now, we can predict these outcomes, and we can show whether those predictions turned out to be accurate, both in specific cases like what happened in India and Nepal, and also more broadly, like what happens to small island nations when larger nations continue to pump carbon into the atmosphere instead of drawing down as quickly as we possibly can. The consequences of these actions can now reasonably be foreseen, and there is no more plausible deniability. Being an optimist doesn't mean you never worry. I still worry. But being a scientist means examining all of the available data. And the data I see tells me that we are getting better at predicting wildfires and floods, at knowing how to protect biodiversity, at seeing which areas are most vulnerable to ocean rising, at forecasting climate-related infectious disease outbreaks, and at managing climate displacement. Prediction isn't a magic wand that makes all of this go away, but it enables meaningful local action. It allows us to proactively and pinpointedly plan and adapt. It lets us turn risk into opportunity. We can't control the storms, but we can see them coming. And that changes everything. It changed me. I didn't become a climate scientist to find hope, but I did. Because the better we get at seeing all of the possible tomorrows, the more power we have to choose the ones we want. Thank you. Thank you. Thank you.